So let's begin. So our present topic is hydrostatics or fluid statics. Now, how do you define a fluid? How do you define a fluid? Some say that something which flows and flies is a fluid. What flows? Liquid flows, and what flies? Gas flies. So fluid is something which flows and flies, flows or flies. Another way of defining fluid is that in the following way. Shear force. What is shear force? The force parallel to the surface is shear force. And a fluid is something a fluid is something which deforms continuously under shear force. Fluid is something which deforms continuously under shear force. So even solids deform under shear force in the following way. I'll show. Say this is a block, a solid block, and the lower end is fixed. And this is the shear force F, force parallel to the surface. So how will the solid deform? Like this, it will deform, and then the deformation is stop. Will stop. Let me draw a better figure than this. The three-dimensional figure. This is a solid block. This is before the shear force is applied. So the lower end is fixed. So the lower end is fixed, and so this is the surface area A. This is the surface, and a force is applied parallel to the surface. So this force parallel to the surface is known as the shear force. And how this deforms? How is the final position of the solid? It is somewhat like this. By this black, I am showing the final position of the solid after deformation. Lines which cannot be seen are drawn by these dotted lines. So this is actually the front view of the three-dimensional thing here. I have drawn in this figure. So this is the view actually. From the front it will look like this. So it will deform by a certain angle theta. Later on, during our topic, in a separate topic, we'll learn about stress and strain. We'll learn about shear force and deformation under shear in more details. So what happens if you apply this type of a shear force on a liquid, say? So on a liquid, say this is say a liquid like this, and say on top of a lake you have a plank, and you apply some force on the plank. So applying force on the plank means you are applying the force on the liquid as well. So does it move and stop? Does the plank move and stop? No, it doesn't. It will keep on moving. It will keep on moving, right? Suppose the plank moves with constant speed, or say on the top surface of the water you apply some force, some tangential force. Then what will happen? The thing will move. The liquid will move. There is no question of deforming by a shear angle and stopping. This will carry on. This will move on. So that is how this definition is justified. Deforms continuously under shear force. Suppose the plank is, say, you apply some force on the plank F, and suppose it moves with constant speed. So water will apply a force F on the plank, and in turn on the topmost layer of water there is a force F. So that is the thing. Or rather, you can forget about the plank and just think in this way. Suppose there is a this is some water or some liquid, and on the top surface you apply some tangential forces. So the water will keep on moving, it will keep on flowing. Or say you have seen that, suppose this is a vessel, a tumbler of glass, and downwards is g gravity. You have never seen a liquid surface like this. Have you ever seen? No, it's not possible. Liquid surface can't stay like this for long. So ultimately it will settle down. Ultimately, after some turbulence, some disturbance, it will settle down like this. Why this happens? See, consider a molecule on the surface, and there its weight is acting downwards. I mean, force weight is acting downwards. Here, see, weight is having a tangential component. It is having a tangential component. If this is theta, see, if this is, I mean, this line is normal to the surface. This red line is normal to liquid surface. If liquid stays like so, there is this component W sin theta. So again, this W sin theta is shear force, because it is the force is tangent to the surface. So liquid can never stay like this. It will flow. It's not stable then. So it flows, moves here and there, and settles down so that the weight and the surface makes 90 degrees, so that there is no component of shear force, no shear force on the uh, molecules on the surface of the liquid, else the liquid will flow. So in the same way you can say that if a vessel, suppose this is a case, next case, a vessel having acceleration a, vessel having acceleration a in horizontal direction. So you have to find the angle made by liquid surface, vessel containing a liquid, obviously na, khali vessel will not work. Vessel containing liquid having acceleration a in horizontal direction, find the angle made by the liquid surface with horizontal. So this thing is like this. So there is a vessel. This vessel is having an acceleration in the horizontal direction. So obviously from common experience you know that this will be the shape of the liquid surface. So you have been asked about the angle, this theta. So how much is this angle theta the liquid surface makes with the horizontal direction? So again the same thing will work here, that the liquids cannot tolerate shear stress or shear force. So the surface of the liquid will be such that there will be no component of shear force, as it was in this case. See, this W sin theta liquid could not tolerate W sin theta, so it chose to have a surface like this, so that there is no W sin theta. I mean this, no shear component, no component parallel to the surface. Now let's have this molecule. So let's this be a particle on liquid on the surface. Now we are looking at it from the frame of the liquid, from the frame of the liquid, or from the vessel frame. See, from the vessel frame. So from the vessel frame, the forces on this particle, suppose the mass is m, the forces on the particle, if the mass is m, there is weight mg, and as it is an accelerating frame, there will be a pseudo force there towards the left. As the acceleration is towards the right, the pseudo force is towards the left, that is ma, and the net force, is the resultant of the two. So this is the net force, is a vector sum of mg and ma. Remember, we are working from the frame of the vessel, and the liquid surface will be such that it will be perpendicular to the net force. Why it should be perpendicular? You know that because then only it will have no component of the force parallel to its surface. Because if there is a component, it will move and the liquid will not stabilize. Okay, so how much is this angle theta? Oh, by the way, this is the same angle theta. This is the same angle theta, right? If this angle between the resultant force, this is the resultant force, angle between the resultant force and vertical direction is the angle between the surface of the liquid and horizontal direction. That is quite obvious, and we know that this tan theta, how much is this tan theta equal to? Tan theta is equal to ma by mg from the vector diagram, so it's a by g. So the liquid will make such an angle theta, which is equal to tan inverse of a by g with the horizontal direction. So vessel along with liquid rotated at angular velocity omega about axis of vessel as in figure. Best way to describe. Okay. Now this is first. Let me draw the figure. So this is the axis right through the middle axis, it is rotated with an angular velocity omega in the following way. So the liquid takes a shape. Liquid takes a certain shape like this. Now I will draw a coordinate system. This is x-axis and this is y-axis. Now question is relative with respect to the coordinate system chosen. Find an equation. Find equation for the liquid surface y. I mean y as a function of x. Y as a function of x. This is actually a view, not the thing is a three-dimensional surface. So just a view. Suppose the front view could be a plane. Okay. So how do you determine or how do you find out the shape, the equation of this liquid surface? I mean this 2D equation. Let me tell you, the shape is a parabola, but the actual 3D shape is a paraboloid. Paraboloid is something, a surface which you get on rotating a parabola about its own axis. Now let's take a particle on the surface of the liquid. This this purple one is the thing. So this is having x coordinate. That means from the axis the distance is x. So there is a centrifugal force on it. If you look from that frame, so there is a centrifugal force on it. If the mass is m, then m radius is x into square of the angular speed, and downward the force is mg, and the net force, obviously the net force is such that at that point the surface is perpendicular to the net force. The surface is perpendicular to the net force. That means the tangent to the surface. So this is this the line which I have drawn is the tangent at that location, where this is the particle. So this is the tangent. So the tangent makes an angle theta with horizontal direction, and from simple geometry we see this the net force vector. The net force makes the same angle theta with vertical direction. So as from the vector diagram we know actually what tan theta is. So tan theta from the diagram is mx omega square divided by mg, that is omega square times x divided by g. Now tan theta is also the slope of the tangent to the curve, so that is dy by dx is equal to tan theta omega square x by g. So dy is equal to omega square by g times x dx. This is the centrifugal force, and mg is the weight, gravity force. Their vector sum is the net force. X is the radius of circular motion of this purple particle. This is the axis. So x is the radius of path of the particle. Every particle, its x coordinate is itself the radius, because this is the axis, x axis and y axis. Consider the particle here. It is moving in a circular path of radius x, because the coordinates are x and y. So this is x is equal to the radius of the path. Okay, so dy. So let's get back to this. Dy is omega square by gx dx. So this is passing through. So the coordinate system choice says that this passes through 0 0. It's showing the upper diagram also. Passes through 0 0. So when we integrate it, so one of the points should be 0 0. So this is x and this is y. So in that way, y is omega square x square divided by 2g. So this is the equation. So actually this is an equation of a parabola.